Well, we meet again. 6.4, rational exponents. First, you have to know, how do you get a rational exponent? Well, we've talked about radicals, and when we have a radical, that is a fractional or rational exponent. Whatever radical, whatever your index is right here, that's the denominator in a fraction exponent. Example, the square root, if there's no number, remember, it's always a 2, is 36 to the 1/2. Cubic root would be like 64 to the 1/3. Fourth root would be 16 to the 1/4. So if I'm simplifying this, you want to do your factor tree and do your prime factorization first. So if I'm going to do my factor tree, first two numbers I can do are 2 and 108. And then keep doing my factor tree. Now there are two ways that you can do this. The first way is, since this is written as to the 1/3 power, I could rewrite this problem as the cubic root of 216. So now I'm looking for groups of 3. So here's a group of 3, and here's a group of 3. That's one way that you could do this. And then you would multiply 2 times 3, and you would get 6. Another way that you could do this, if you wanted to do it this way, you have 3 2's, and you have 3 3's, and all of these are to the 1/3 power. So your properties of exponents is a power to a power you multiply. So I could bring that in, which would give me 2 to the first times 3 to the first. Both of them will give you the option of 6. So 6 would be my answer here. So I'm looking at my second one. This is where I would just do my properties of exponents, because 7, my base number, is already prime. So I'd have to just add my exponents. Again, your property of exponents. So the base number does not change. You do not change. So it's 7 1/2 plus 1/2, because since you're multiplying, you're adding the first power. That's your final answer. So these other ones, I'm going to do C, and then I want you to try D, E, and F. So for C, I notice that I can rewrite this as 5 to the 1/4 times 125 is the same thing as 5 cubed to the 1/4. Now again, here I can do power to a power right there. So I have 5 to the 1/2 times, and I meant 1/4, sorry about that, 5 to the 1/4 times 5 to the 3/4. Power to a power you multiply. So now since these have the same base, I can have the same base of 5, and I'm going to right here add my exponents. 1/4 plus 3/4 would give me 1. That's my answer. So I want you to try to do D, E, and F by yourself. So I'm looking here. Here's a little property that we have. So a fraction exponent is the same thing as a root, just like here. When you're taking that fraction exponent, you can rewrite it either way, like this. Both of these are the same thing. When we're doing this, we are assuming that if m is negative, that a cannot equal 0. Because if m is negative and a was equal to 0, we would be undefined because it would be on the bottom of a fraction. So first, just converting in between exponential to radical form. When you're looking at this, you'll always want to look at the bottom of your fraction right there. That will tell you what your index is. So my index is 7. So little 7 here, and then this would be x cubed. Again, you could rewrite it this like this. I will always prefer, personally, to rewrite it this. So my second one, y. First I have to rewrite that as a fraction exponent. So that's going to be the same thing as negative 7/2. Now there's two different steps you could go about doing this. You could rewrite the radical and then get rid of the negative, but your answer should not have any negative roots. I personally am going to do this. 1 over, and then I'm going to have my 7th, or my half, right here, over y to the 7th. So where am I getting this? The negative is where I have a fraction. The denominator is my index. You don't need to have that 2 written there, but you can have the 2 written there. And the 7 is my exponent. I need to simplify this now. So when I'm simplifying this, I first can see that I can take out 3 groups, because I could rewrite this as 1 over, this would be the same thing as the square root of y to the 6 times y. which is 1 over y cubed over the square root y. So now I have to rationalize that. So when I rationalize that, I'm going to multiply by square root of y over square root of y. Because this is looking at pairs, so on top I have the square root of y over, this becomes y cubed times the square root of y squared, because of this y times y, and the square root of y squared is y cubed times y is y to the 4th. So this would be my final answer. Bing bada boom. The next one, if I'm going from radical to exponential. Again, if there's no number shown, it's always a 2. So in this case, this is a raised to the 5 halves. No index here, it's always a 2. This is just rewritten the same way. My index is going to be my denominator, so I'm going to have b cubed to the 5th, because my index here is 5. That's why my denominator is 5. So I want you to try C and D, push pause, and try C and D by yourself. So now we're just basically going over the same thing that we did at the beginning of this chapter, the 6.0. So properties of exponents, but now they're just kind of special because they're fractions. And sometimes people get really scared of fractions, but they're not scary. Trust me, they're not scary. So combining radical expressions. So first thing you're going to do for all of these problems is rewrite it so it has a fraction exponent. So on top here, I would have x to the 3/4 over x 2 divided by 8. I can simplify 2 divided by 8. That's the same thing as x to the 3/4 over x to the 1/4. Now when I'm simplifying this, there is always taking your top minus your bottom. There should be more on top, so your answer is not going to be in a fraction. So I do 3/4 minus 1/4. That's the same as 1/2. So my answer would be x the 1/2. Because 3/4 minus 1/4 is 2/4, and that's the same thing as 1/2. That's my final answer. So for this first one, you can only do this if you have the same base. So this next one, this is the same thing as rewriting as 3 to the 1/3 times 3 to the 1/4. Now, when we did this before, and we just had the radicals, we would say, oh, I can't do that because the indexes are different. When we change this now into exponential form, now we have that property of exponents, because we know that when we're multiplying, we can be adding our exponents. The thing you do not want to forget for this problem is my base here is 3. So my answer should have a base of 3. And then I take 1/3 plus 1/4. If you're not good at adding your x or your fractions, you can use your calculator. Or else you can come in and I can give you help on how to a refresher course on adding, subtracting fractions. So you should pause the video and try C and D by yourself. And here, simplify numbers with rational exponents. So I'm going to leave my answer as an exponent, but you have to simplify it. So the first thing I'm doing, kind of like at the beginning of this video, we're going to rewrite 16 in prime factorization. Now, one thing that happens a lot is that you come up with the same numbers, like 16, 32, and you might start getting to know the base 2 property. So this is 2 raised to the 4th power. That's what 16 is. I'm going to rewrite negative 2.5 as a fraction, negative 5.5. Now, one thing you have to be careful with negative numbers, because when I have this number right here, this has to be positive in order to do an even root. That's the same thing as an even index. But now I have my properties of exponents that I'm going to apply. So first thing that I could do is I could either do this power to a power first and then simplify with this negative, or else I could take care of the negative first. Either way, you should get the same answer. I'm going to do my power to a power, so that means I'm going to multiply right here. So this becomes 2, and negative 5/2 times 4 would give me a negative 10. That should not be your final answer. That's the same thing as 1 over 2 to the 10th. And 2 to the 10th is the same thing as 1 over 1024. So that right there would be my final answer. Now when I'm looking at this next one, again, I have a negative number, but I have an odd root. So that's fine. I can have a number with an odd root. Same thing though here. First I'm going to rewrite this as with my prime factorization. So this would be negative 2 raised to the 5th power That's negative 32 is the same thing as negative 2 raised to the 5th power. And now I have 4/5. One thing I notice here is that this 4 right here is going to turn my answer positive. So when I have this power to a power when I multiply this, one thing it might be helpful to do is saying this is negative 2 raised to the 5th power. So now when you do this power to a power, that becomes 5 times 4/5, which is the same thing as negative 2 raised to the 4th. And negative 2 raised to the 4th is going to give me 16. So my answer here would be 16. So I want you to try to do C and D by yourself. C and D. And the last two I'm going to do before you do C and D, and then we're going to be done with this video, is what is each expression in simplest form. So right away when I'm looking at this, I'm going to rewrite my inside. So I'm going to write negative 8, that's the same thing, whoopsie daisy, as negative 2 cubed. And then I have my x value, that's to the 1st power. This will give me x, y to the 1/2 power. And then this whole shebang is raised to the 2/3 power. So we want to see how this simplifies. So one thing that I notice is that I have a power to a power. When I'm doing this power to a power, I have to be careful. So I can either do this power to a power first, or else I can do this power to a power first. I always personally like to work inside and then out. So I'm going to rewrite this. So this becomes negative 2 to the 3rd, x to the 1st, x to the 1/2, y to the 1/2, the whole shebang to the 2/3. Now before again I do that power to a power, I notice that these two have the same base. And since these two have the same base, I can add those two exponents. So again I have negative 2 raised to the 3rd power times x to the 3/2, because 1 plus 1/2 is 3/2, times 1/2 to the 2/3 power. And now I can do my power to a power all across the board. This becomes negative 2 squared. This becomes x to the 1st, 3/2 times 2/3 would be the 1st, and this becomes y to the 1/3. So then my final answer when I rewrite this would be 8x, and then the cubic root of y. Next one. So again, 16 is the same thing as 2 to the 4th. So I'm going to rewrite 2 to the 4th here. Y to the negative 8. The one thing that I notice about this right here, because I have a negative on the inside and on the outside, I'm actually going to simplify my power first before I do my negative exponent. Because I'm going to give my power to a power right here. This becomes 2 to the negative 3rds. 4 times negative 3/4 would be negative 3. And the second one becomes a positive 6. I don't need those parentheses. I don't know why I wrote them, but I wrote them. So now my final answer, this is the only one that has my negative exponent, and I don't want any answers with negative exponents. Oops, I meant to push this right here. It's my negative exponent. So my final answer would be y to the 6, because that's a positive exponent, over 2 to the 3rd. The same thing, y to the 6 over 8. And there you have it. That's all she wrote. And by she, I mean me. You have a great, grand, wonderful day.